Hi friend, this is Samir, and today I'm going to discuss about the transducer part. And this is our question. The question is, the output of Lvdt is connected to a 5 volt voltmeter through an amplifier whose amplification factor is 250. An output of 2 millivolt appears across the terminals of Lvdt when the core moves through a distance of 0.5 millimeter. Calculate the sensitivity of Lvdt and that of whole setup. And it is given that the millivoltmeter has a scale of 100 divisions. The scale can be read up to 1/5 of a division. Calculate the resolution of the instrument in millimeter. So let us solve this question. We are going to find the solution of this question, and first of all, in this type of question, we will have to draw the block diagrams of the elements given in the question. So we have 3 elements here, like Lvdt, first one, second one is our amplifier, and third one is voltmeter. So I am going to draw the block diagram of the given circuits. Now in the question it is given that if core is displaced by 0.5 millimeter, 2 millivolt appears across the terminals of Lvdt. So the input of Lvdt is 0.5 millimeter and the output of Lvdt appears across this terminal is 2 millivolt. And amplification factor of this amplifier is given as 250. So we can write the amplification is given as 250. Now our first question is, we have to find the sensitivity of Lvdt, and we know that the sensitivity is nothing but the ratio of change in output by the change in input. So in our case, for this Lvdt, the sensitivity is this is the sensitivity of Lvdt, and as per our given data, the output of Lvdt is given as 2 millivolt and the input of Lvdt is 0.5 millimeter. 0.5 millimeter means our sensitivity is 4 millivolt per millimeter. This is the sensitivity of Lvdt. This is the sensitivity of Lvdt. Now, the second question is, we have to find the sensitivity of whole instrument, and we know that the sensitivity of whole instrument is the multiplication of individual sensitivity of the instruments. So the sensitivity of whole instrument equals to the sensitivity of individual instruments. like sensitivity of Lvdt into sensitivity of this amplifier, and the sensitivity of amplifier is nothing but the amplification given. Actually, the sensitivity is like gain in the control system. Like sensitivity of this amplifier is given as 250, means amplification factor is given as 250. That's why the sensitivity of whole instrument is equals to sensitivity of Lvdt into amplification factor, and that is equals to sensitivity of Lvdt. We have already got that 4 millivolt per millimeter. So this is 4 millivolt per millimeter into the amplification is given as 250. That's why I'm writing it as 250, and that is equals to 1 volt per millimeter, and that is equals to 1 volt per millimeter. The sensitivity of the whole instrument is 1 volt per millimeter. Now the third question is we have to find this resolution of the instrument. So resolution is nothing but the minimum resolution is called as sensitivity. We know the minimum resolution in the minimum range is called as sensitivity. So we have to find first the resolution of our voltmeter, and as per the given data, the resolution of voltmeter is this voltmeter measures maximum voltage of 5 volt and it has 100 divisions. So we can say that it having 5 volt by 100 division means that is equals to 0.05 volt per division. It will measure 0.05 volt per division. Now it is given that the scale of voltmeter will read up to 1/5 of per division. 1/5 of division means it will read 1/5 of division, that is equals to 0.01 volt. Now the resolution of our voltmeter is 0.01 volt as per our given data. So we have already find. Now we have to find this resolution of whole instrument. Now the resolution is nothing, as I have already described, resolution is nothing but the sensitivity is nothing but the minimum resolution in the minimum range. That's why means sensitivity is the resolution in the minimum range. That's why I'm writing it here like resolution of instrument is equals to 1 by sensitivity into resolution of voltmeter. Now we have already found the value of sensitivity. We have already found now what is the value of sensitivity we have found. We have found the sensitivity value is 1 volt per millimeter, and now we have got the resolution of voltmeter is 0.01 volt. That's why I am writing directly 1 by 1 volt per millimeter into 0.01 volt. Now the answer is 0.01 millimeter. The resolution of the instrument is 0.01 millimeter. The resolution of instrument is 0.01 millimeter is our final answer. So we have got the answer of our question. Now we are going to solve another question. Now we are going to solve this question, and the question is given as a platinum resistance sensor is to be used to measure temperature between 0 to 250 degrees C. The resistance RT ohm at T degree C is given by RT equals to R naught into 1 plus alpha T plus beta T square, and where R naught is given as 100 ohm, R100 means R at T equals to 100 degrees C is given as 138.50 ohm, and R250 degree C is given as 175.83 ohm. Calculate the value of alpha and beta. Also calculate the non-linearity at 100 degree C as the percentage of full scale deflection. Let us solve this question first. So, the relation between resistance and temperature in the question is already given, and the relation was RT equals to R naught into 1 plus alpha T plus beta T square. It is already given in the question, and the resistance at particular temperature is also given in the question. So R naught is given as 100 ohm. R100 means resistance at 100 degree C is given in the question as 138.50 ohm, and R250 degree C is also given as 175.83 ohm. 175.83 ohm. It is already given in the question. Now first we have to find the value of alpha and beta. These are the constants we are going to find. So we just have to put the different temperatures in our relation RT equals to R naught into 1 plus alpha T plus beta T square. So in this way we will get two equations, and we will have to find the value of alpha and beta from there. Now we are going to find that value of alpha and beta. .50 ohm is equals to R naught is given as 100 ohm. So I am writing here 100 ohm into 1 plus alpha. I am putting temperature as T equals to 100 degrees C. That's why I am writing 100 plus beta into 100 square. This is our first equation, and if we solve this equation, we will get the value of we'll get the relation like 1 plus alpha into 100 plus beta into 100 square equals to 1.3850. Now alpha into 100 plus beta into 100 square is equals to 0.3850. So we can write it as alpha plus beta into 100 is equals to 0.03850. And suppose this is our first equation. Now we are going to put T equals to 250 degrees C in our given relation. So from here 175.83 equals to 100 into 1 plus 250 into alpha plus 250 square into beta. This is the relation. So we will get alpha into 250 plus 250 square into beta is equals to 0.7583, and this is our second relation. This is our second relation. After solving these two equations, we will get alpha equals to 3.3054 into 10 to the power minus 3 per degree C, and beta equals to minus 5.54 into 10 to the power minus 6 per degree C. After solving these two equations, equation 1 and equation 2, we will get this value of alpha and beta. Now, we will have to find the maximum percentage linearity with respect to the full scale deflection. So, we will have to find the actual value of resistance at 100 degrees C. So, suppose actually the resistance versus time graph, suppose it is actual line, straight line. Now this is our given data, this is our given relationship, that is RT equals to R naught into 1 plus alpha t plus beta t square. So it is given that at t equals to 0 degree C resistance is 100 ohm, at t equals to 0 degree C resistance is given as 100 ohm, and at t equals to 100 degree C, it is given as the resistance value is 138.5. Suppose at t equals to 100 degree C, the resistance is given as 138.50 ohm. At t equals to 250 degree C, the resistance is 175.83 ohm. At t equals to 250 degree C, suppose this is 250 degree C, the resistance is given as 175.83 ohm. Now we have to find the value of actual resistance at t equals to 100 degree C. So we have to find this value. We know this is a straight line. We have the relation between resistance and temperature as a straight line. So we can write the resistance R equals to K into T plus C. So we can write this relation as a straight line. At time t, at temperature T equals to 100 degree C, this resistance is 100 ohm. That's why this C value is nothing but 100 ohm. This C is equals to nothing but 100 ohm. As at time T equals to 0 degree C, the resistance value is 100 ohm. So friend, I am going to wipe this one. Now we have to find the value of K. K is the constant. Now we know that at T equals to 250 degree C, at T equals to 250 degree C, this resistance value is 175.83 ohm. It is given. So I am putting this value 175.83 is equals to K into 250 plus C is nothing but 100 ohm. 100 ohm. So our K value is given as 175.83 minus 100 by 250, and it is nothing but this value is almost equals to 0.30. This K is approximately equals to 0.30332. So we have to find the value of resistance at 100 degrees C. Now I am just putting R equals to 0.30332 into 100 degrees C plus 100 ohm. Now this value you will get 100 plus 30.332, and that is equals to 130.332 ohm. Now we can see that we have got the at temperature T equals to 100 degrees C, we have got the value of resistance is equals to 130.332. This value is 130.332 ohm. Now the maximum non-linearity. The maximum non-linearity at the temperature 100 degrees C is at T equals to 100 degrees C. Non-linearity is equals to 138.50 minus 130.332, and that is equals to 8.7, approximately 8.7 or 8.17 ohm. It is equals to 8.17 ohm. Now we have to find the nonlinearity, percentage nonlinearity with respect to full scale deflection. Now we have to see the full scale value. Here in our question, the full scale value is nothing but 175.83 minus 100 ohm, because at temperature 100 degrees C the resistance is 100 ohm. That's why the FSD is equals to 175.83 minus 100 ohm, and that is equals to 75.83 ohm. Now the percentage non-linearity is equals to 8.17 by 75.83, and that is equals to into 100%, and that is equals to 10.71%. And this is our final answer. Now our question is, a barium titanate pickup has the dimension of 5 mm into 5 mm into 1.25 mm. The force acting on it is 5 Newton. The charge sensitivity of barium titanate is 150 picocoulomb per Newton and its permittivity is 12.5 into 10 to the power minus 9 Newton per meter square. Calculate the strain, charge and the capacitance. So this question belongs to the piezoelectric transducer, and we are going to solve this question. Let us solve this question. We know the piezoelectric crystals having 3 axes. Namely, I am just drawing piezoelectric crystals. Suppose this is our piezoelectric crystals. And these are the 3 axes of this piezoelectric crystal. Now, this y-axis, this is x and this is z-axis of the crystal. This is z-axis of the crystal. This y-axis is called as mechanical axis. This y-axis is called as mechanical axis. This x-axis is called as electrical axis. And now this z-axis is called as optical axis. Now we know that these piezoelectric crystals are actually an active transducer. If we apply some mechanical stress, if we apply some mechanical force, some force on y-axis or on this surface, we'll get some charge accumulated on this surface, on electrical axis. On electrical axis, we'll get some charge. So, this is an active transducer because we are applying some force without having any auxiliary source. This is producing some charge. This crystal is producing some charge. That's why these piezoelectric crystals are like active transducer. Now, here it is given as the thickness of this crystal is 1.25 millimeter. It is mentioned in the question. And the height and width of this piezoelectric crystals are 5 millimeter each. That's why we can say that the area of this piezoelectric crystal is 5 millimeter into 5 millimeter and the thickness is approx 1.25 millimeter is already given in the question. Now we have to find the value of strain. No, we know that as per the Hooke's law, stress is directly proportional to strain, and the stress is nothing but the force per unit area, and that is equals to Y into strain, where Y is modulus of elasticity. Y is modulus of elasticity. So we have to find the value of strain. That's why this is our strain. So strain is equals to F, force per unit area, into 1 by modulus of elasticity, and we can say that it is Young's modulus. So in the question, force value, force applied is given as 5 Newton. Force applied is given as 5 Newton. And area, as we have already discussed, is 5 millimeter into 5 millimeter. That is equals to 25 into 10 to the power minus 6 meter square is our area. And the modulus of elasticity of barium titanate is given as 12 into 10 to the power 6 Newton per meter square. We just have to put these values in our given equation. So the strain is equals to 5 Newton by 25 into 10 to the power minus 6 meter square into 12 1 by 12 into 10 to the power 6 Newton per meter square. This is equals to 1 by 60, that is equals to 0.01666, and this is our calculated strain. This is our calculated strain. Now the second question is calculate the charge. Calculate the charge accumulated on the electrical axis. So we have to find the charge, and we know for piezoelectric crystal this charge Q is directly proportional to this force applied. We know the relation, this charge Q is directly proportional to the force applied. So we have to remove this proportionality. So we can write Q equals to D into F, where Q equals to D into F, and this coefficient D is known as charge coefficient. This coefficient D is known as charge coefficient. It is already given in the question. The charge coefficient value is given in the question. This charge sensitivity, it is also known as, this coefficient is known as the charge sensitivity, and it is given as 150 picocoulomb per Newton. So this charge developed is equals to 150 10 to the power minus 12 Coulomb per Newton into 5 Newton. That is equals to 750 picocoulomb. This charge generated Q is 750 picocoulomb. Now we have to find the capacitance value, and we know the capacitance formula is C is given as epsilon into A by this thickness T. Epsilon into A by thickness T, where epsilon is the permittivity of barium titanate, and all values are given in the question. So permittivity of the barium titanate is given as 12.5 into 10 to the power minus 9 farad per meter. Area is already given 25 into 10 to the power minus 6 meter square, and the thickness is given as 1.25 into 10 to the power minus 3 meter. So it is approximately 12.5 into 25 by 1.25 into 10 to the power minus 12 farad. That is equals to 250 picofarad. The capacitance value is 250 picofarad. The capacitance value we have got is 250 picofarad. Suppose we have to find the value of voltage generated. The value of voltage generated. So we have one more relation in this piezoelectric transducer, that is this value E naught. Suppose voltage generated is equals to E naught is equals to this G into the thickness and force per unit area. This is the relation to find the voltage generated across the terminals of this piezoelectric crystal, where G is nothing but the voltage sensitivity. The G is nothing but the voltage sensitivity of the piezoelectric crystals. Now there is a relation between this G, voltage sensitivity, and the charge sensitivity, and that is G equals to this charge sensitivity by epsilon into thickness into force upon area. So if we put all we'll get the value of E naught is 3 volt. So our next question is from flow measurement, and this is a pitot tube is to be used to measure the speed of an aeroplane. Pressure differential is measured by a U-tube manometer using water. The density of air is 1.22 kg per meter cube. If the reading of manometer is 80 millimeter of water, then the velocity correction factor is given as 0.98. Calculate the velocity of aeroplane. Assume that the air is incompressible. Now, the reading of the manometer is given in terms of water, but our flowing fluid in pitot tube is nothing but air. So, we have to find the reading in terms of air only. Then we can put these values in our pitot tube formula. Now we are going to solve this question. Let us solve this one. We know that pitot tube measures static pressure, local velocity. It measures some local velocity at a particular point in flowing duct. So, we know that the velocity V equals to CV, some velocity correction factor, and this is given as 0.98 in our case, CV into root under 2 into P stagnation minus P static by rho of flowing fluid. Here the flowing fluid is given as air. So the rho of air. Now this differential pressure P stagnation minus P static is found by using U-tube manometer. Suppose this is our U-tube manometer and the manometric fluid is water. In the question it is already given. Suppose this is water, manometric fluid is filled. And suppose this manometer is attached in pitot tube. Now, suppose let us take this as a reference point. We know this is flowing fluid air. Suppose the height is, it is given as HM. This height is given as H. This height is given as H. Now, at this reference point, we can write the pressure equation. Suppose the pressure here is P1 and the pressure here is P2. Now we can write two equations for left limb of this manometer, P1 plus rho of air into G into H is equals to this P2 plus rho of water into G into H. We can write this equation at some reference point. Now we can write it as P1 minus P2 equals to rho of water into GH minus rho of air into GH. And we can write it as some modification we have to do. So I am taking rho of air into G into H as common. So it is equals to rho of water by rho of air minus 1. Now, this pressure differential del P is measured already by means of some YouTube manometer. Now, we have to put this value in our equation. So, we will get this V equals to root under 2G into HM, where HM is nothing but this thing only. This is our HM. So this HM is equals to H into rho of water by rho of air minus 1. So we know that the density of water is nothing but 1000 kilogram per meter cube. So we are putting these values. H value is already given is 80 millimeter of water. So this is 80 into 10 to the power minus 6 by 1000, 1.22 minus 1. Now we can put these values in our equation. This V equals to root under 2 into 9.8. The G value is 9.8 meter per second square, and into 80 into 10 to the power minus 6 into 1000 by 1.22. This ratio 1000 by 1.22 is much more greater than 1. So we can neglect this 1. So we'll get the velocity of this air is approximately equals to 35.133 meter per second. And this is what we have asked to calculate the velocity of air. So our question is the average velocity V of flow of clear water in a 150 centimeter inner diameter tube is measured using the ultrasonic flow meter as shown in the given figure. The angle theta is 60 degree. The measured transit times are T1 equals to 0.9950 millisecond and T2 is equals to 1 millisecond. The velocity V in meter per second in the pipe is dash. This is a net type question. We have to find the velocity of flowing fluid from this flowing duct. So now let us solve this question. We know that the ultrasonic flow meters are of two types. One is transit time type and second one is Doppler shift type. In Doppler shift we are using frequency, but in transit time type we are using the transit times. So this question based on transit time Doppler, transit time ultrasonic flow meter. Now here we have seen that in our question the velocity of sound is not given. Velocity of sound is not given. So we have to proceed in this question in a conventional way. So let us solve this one. This distance is pipe diameter is given as 150 centimeter. But we have to find the velocity here in this direction. That's why we have to find this distance. Suppose this distance is L. Suppose this distance is L. So angle theta is already given in the question is 60 degree. So we can write equation like L equals to this sin theta, sin 60 degree equals to this sin 60 degree equals to 150 centimeter by the given distance L. Now this L is equals to 150 centimeter by sin 60 degree. And we know that the value of sin 60 is root 3 by 2. So this is 150 centimeter by root 3 into 2, and that is nearly about 173.205 centimeter. That is equals to 173.205 centimeter. We can write it in meter also. So this is approximately 1.73205 meter. This is approximately 1.73205 meter. Now we have to find the velocity. So here T1 is given as 0.9905 millisecond and T2 is given as 1 millisecond. So T1 is less than T2. So we have to consider upward flow as well as downward flow. In downward direction, the transit time will be less. In downward direction, the transit time will be less, and in upward direction, it will be, in downward direction, the transit time will be more, and in upward direction, the transit time will be less. So, I am writing T1 transit time is equals to, we have to go through a conventional way. T1 is equals to this V, this L by V. Suppose I am writing Vs as a sound velocity Vs plus minus V cos theta. Here V, I am writing V as a fluid velocity which is flowing through the flowing conduct. Now V is our fluid velocity. So L Vs minus V cos theta, I am writing T1. And T2 is equals to L by Vs plus V cos theta. I am writing T2 as L by Vs minus V cos theta because T2 is given as 1 millisecond, that is more. Okay, that is more. So this should be less. So this T2 will be L by Vs minus V cos theta, and this T1 will be L by Vs plus V cos theta. This T1 will be L by Vs plus V cos theta. Now we are just going to put the values of T, theta and this L. So we'll get two equations from here. So T2 is given as 1 millisecond. This is 1 millisecond equals to this L we have already found 1.73205 meter by this Vs is not given, Vs minus V cos theta. Theta is 60 degree. 60 degree. So we can write this Vs minus V cos theta is equals to 1.73205 millimeter by 1 millisecond. So this is 1732.05 meter per second. Suppose this is our first equation. Suppose this is our first equation. Now, this T1 is given as so our Vs plus V cos theta, Vs plus V cos theta is equals to 1.73205 by 0.9950 millisecond, and this is approximately equals to 1740.73 meter per second. This is our second equation. Now we can solve this equation 1 and equation 2 and we'll get the value of V. So Vs plus V cos theta is equals to 1740.73 meter per second, and this Vs minus V cos theta is given as 1732.05 meter per second. So these are the two equations we have got, and after solving we'll get the value of V as 8.7 meter per second. The value of V and this is our required answer. This is our required answer. This is the velocity of flowing fluid from the duct. Now, the next question is from level measurement. So, the question is two concentric tubes of length 8 meter and diametric ratio of 2 are used as a capacitive level transducer to measure the depth of H of the liquid in a tank. The liquid depth varies between 0 and 7 meter. The dielectric constant of the liquid is 2.4. and the permittivity of free space is 8.85 picofarad per meter. It is given. The transducer is incorporated in the breeze as shown in the figure, and this is our figure already given in the question. So our first question is to calculate the value of adjustable capacitance C1. Calculate the value of adjustable capacitance C1 so that the open circuit breeze voltage is V0. The open circuit breeze voltage V0 to 0 when the tank is empty. We have to find the value of C1 so that the value of V0 will be 0 when the tank is empty. So we are going to find the value of C1 adjustable capacitance. First of all, we have to find the value of CS. That is, when the tank will be empty, then we have to find the value of C of S. This C of S. So let us solve this question now. So we know the formula for cylindrical capacitance. So this CS will be equals to 2 pi epsilon into L, that is the height of transducer, capacitive transducer, the length of capacitive transducer, by ln d naught by di. This d naught by di is the diametric ratio. It is already given in the question as 2. Now we have all the values. When the tank is empty, then this transducer, this capacitive transducer is filled up with air only. So we can write this as 2 pi epsilon r into epsilon naught into L by ln d naught by di. So this epsilon r will be 1 when tank is empty. When the tank is empty, then epsilon r will be equals to 1. So we have to put all these values. 2 into 3.14 into epsilon naught is given as 8.85 into 10 to the power minus 12, and the length of the transducer, capacitive transducer, level measurement transducer, is given as 8 meter. So we are putting this value 8 meter by ln 2, because the diametric ratio d naught by di is given in the question as 2.0, that is 2. So if we find this value, we will get 641.45 picofarad. 641.45 picofarad. This is the capacitance value Cs. Now we have to find the capacitance value C1 for which the bridge is balanced. Now we know the condition. If bridge is balanced, for balanced bridge, 1 by SC1 into that 10 kilo ohm equals to 1 by SCS into that 100 ohm. We can write the bridge balance formula. So from here C1 is equals to this 10 kilo ohm by 100 ohm into CS, and that is equals to 100 into 641.45 picofarad, and that is equals to nothing but 641.45 into 10 to the power minus 10 farad, that is equals to 64.145 nanofarad. This C1 at the balance condition is equals to C1 equals to 64.145 nanofarad. Now the next question is find the output voltage when that given tank will be full. When the tank is full, then we have to find the value of V naught. Okay, so when the tank is full, we have to find the capacitance value. The capacitance value of the level measurement transducer. the height of tank when it is full is 7 meter. It is already given in the question. And the height of this remaining capacitance transducer, level measurement transducer, is 1 meter, because the length of total this capacitive transducer is 8 meter. In the question it is already given. This is 8 meter. In the question it is already given. Now here two types of capacitance is forming. One for this liquid, when the medium is this liquid, and another for when the medium is only air. For liquid, the permittivity is given as epsilon r equals to 2.4, and for air this is epsilon r equals to 1. Now we are going to find these two values. So this total capacitance C, this total capacitance Cs will be equals to 2 pi epsilon naught into epsilon r into L, that is 7 meter for liquid, 7 meter by ln d naught by di plus 2 pi into, for other case air is the medium, for 1 meter height the air is the medium, that's why the epsilon r value for air is equals to 1. So I am writing epsilon naught into 1 by ln d naught by. So we can write it as 2 pi epsilon naught by ln d naught by di into 7 meter into epsilon r plus 1. This is our formula for overall capacitance Cs. So we can put the value, so 2 into 3.14 into 8.85 into 10 to the power minus 12 by ln 2 into 7 into 2.4 plus 1. If you find this value, we'll get the capacitance value will be equals to 1.427 nanofarad. This CS will find this CS as 1.427 nano. This is our required capacitance. This value of capacitance we have got. Okay. Now we have to find the voltage V0 across that breeze in case when the tank is full. So now this capacitance we have got for full tank. That's why we are going to take that breeze again, and the breeze is given as like this one. This is V0. Suppose this is plus, this is minus. Okay. So this is our CS. This is C1, adjustable capacitance, and 15 volt source is here. Written 15 volt source Vs is 15 volt. Now this is given as 100 ohm and this is 10 kilo ohm. Now we notice this V0, we can write this V0 equals to this 15 volt means source into 10 kilo ohm by 10 kilo ohm plus 100 ohm minus 1 by SCS by 1 by SCS plus 1 by SC1. So 15 volt into 10 kilo ohm by 10 kilo ohm plus 100 ohm minus C1 by C1 plus CS. So find this value, if we put all these values, we'll get V naught output equals to 177 millivolt approximately. We'll get this V naught equals to 177 millivolt. So this voltage is for full tank. Whatever asked in the question, we have to go through this. Only we have to follow this process only. So this is our required answer. This is our required voltage across the bridge. So our question is from temperature measurement, and this is a question of thermocouple. Now the question is, a thermocouple based temperature measurement system is shown in the figure. Relevant thermocouple EMF in millivolt data is given below. The cold junction is kept at 0 degree C. The temperature is 30 degree C in the other part of the system. The temperature of the hot liquid is what? So we have to find the temperature of the hot liquid from this given data. Some data in this table is already given in the question. Now let us solve this question. So this thermocouple is made up of copper, constantan and chromal metals. So we can replace this circuit, this thermocouple, by an electrical equivalent circuit. So how can we replace? We just have to take battery instead of this copper chromal constantan and constantan copper. So this voltage is already given in the question is 26.74 millivolt. This voltage V naught is already given in the question 26.74 millivolt. Now we are going to replace this whole thermocouple by an electrical equivalent circuit. This is our V naught, which is given as 26.74 millivolt. And now this battery is for copper chromal. So we can write the EMF of this is E copper chromal. And this battery is for chromal constantan. This battery is for chromal constantan. And this is constantan, both are same. That's why we can't replace this junction as a battery. So we are just going to replace this junction as a battery of EMF E chromal constantan. So this is E chromal constantan. Now we can apply KVL equation here. So we can write minus V naught plus E copper chromal plus E chromal constantan equals to 0. So our V naught is equals to E copper chromal plus E chromal constant. So this E copper chromel is kept at 30 degrees C, as already given in the question. The cold junction is kept at 0 degrees C and the other part of the junction is kept at 30 degrees C. So this E copper chromel is at 30 degrees C and this E chromel constant we are taking here at hot junction. So this will be at T degree C. Okay. Now from this given data, from this given table, we can write E copper chromel at 30 degrees C as, so we don't have E copper chromel, so we have to find the E copper chromel, means EMF of copper chromel in terms of copper constant and chromel constant. We know E copper chromel equals to E copper constant minus E chromel constant at 30 degrees C. E copper chromel equals to E copper constant minus E chromel constant at 30 degrees C. So from this given table, at 30 degrees C, E copper constant in millivolt is given as 1.196 millivolt. This is given as 1.196 millivolt minus E chromel constant at 30 degrees C is given as 1.801 millivolt. It is given as 1.801 millivolt. And this is nothing but minus 0.605 millivolt. This E copper chromel we have got is minus 0.605 millivolt from this given table. Now we have to find the temperature of the hot liquid. So the value E chromel constant at T degree C equals to 26.74 minus 0.605 millivolt, and that is equals to 27.345 millivolt. E chromel constant at T degree C is given as 27.345 millivolt. Now, from the given data, this E chromel constant will give 27.345 millivolt at T equals to 380 degrees C. As per the given data, this EMF 27.345 millivolt will get at temperature 380 degrees C. So our answer is the hot liquid temperature T degrees C will be equals to 380 degrees C. This temperature T will be equals to 380 degrees C. So this is our required answer. So the next question is from pressure measurement, and this question is a steel diaphragm is used for pressure measurement. It is 50 millimeter in diameter and is to be designed to measure maximum pressure of 1.5 mega Newton per meter square. The modulus of elasticity of steel is 200 giganewton per meter square and Poisson's ratio is 0.3. Calculate the thickness of diaphragm in order that maximum deflection is not more than 1/3 of its thickness. Calculate the natural frequency of this diaphragm. The density of the steel is 7800 kg per meter cube. So let us solve this question. So our given data is the diameter is given as 50 millimeter. The diameter of the diaphragm is given as 50 millimeter and the maximum pressure Pmax is given as 1.5 mega Newton per meter square. The modulus of elasticity of steel is given as 200 giganewton per meter square and the Poisson's ratio is given as 0.3. In the question, it is given that calculate the thickness of diaphragm in order that the maximum deflection is not more than 1/3 of its thickness. Now, I am writing dm as maximum deflection of the diaphragm should be equals to 1/3 of the thickness. I am writing T as a thickness. T, thickness of the diaphragm. And I am writing dm as a maximum deflection of the diaphragm. So, it is given that rho steel equals to 7800 kilogram per meter cube. It is already given in the question. Suppose this is our diaphragm. This is our diaphragm. After applying some pressure on it, it deflect by its mean position by dm. Suppose it deflects by dm. Now, the diameter of this diaphragm, I have taken it as D. D is the diameter of the diaphragm. Now, this deflection, I have written it as dm. The deflection, I have written it as dm. Now, this is the thickness. This is the thickness of the diaphragm. Now, we know that the pressure, applied pressure P is equals to 256 into Young's modulus. I have written it as Y or modulus of elasticity. I am writing it as Y of steel into TQ into this deflection dm by 3 into 1 minus Poisson's ratio square into diameter whole 4. This is the relation between pressure and the deflection dm. This is the relation for diaphragm or pressure and the deflection dm. So we have to find the thickness of the diaphragm. So we can write this thickness TQ equals to 3 into P into 1 minus V square into D4 by 256 into Y of the steel into dm. We can write this formula. So we can replace dm by 1 by t. We can replace this dm by 1 by t. So we can write this t square. We have written it as 1 by t. So T square is equals to 3 into maximum pressure is given as 1.5 meganewton per meter square. 1.5 into 10 to the power 6 into 1 minus B square means Poisson's ratio square. Poisson's ratio is given as 0.3, that is equals to 0.09 into diameter already given is 50 millimeter, that is 2500 into 10 to the power minus 6 meter square. I have written it in meter by 256 into Y of steel means Young's modulus for steel is already given as 200 giganewton per meter square. 200 into 10 to the power 9 into this dm, deflection dm we have already taken as 1 by t. We have already taken dm as 1 by t. If we solve this one, we'll get thickness is about 5 millimeter, or we'll get thickness 4.94 millimeter. This thickness is 4.94 millimeter. Now we have to find the natural frequency from which this diaphragm will oscillate. So this omega n, natural frequency omega n is equals to, we know the formula, 20t by d square root under E by this E is nothing but Y steel by 3 into rho into 1 minus V square. All the values are given. If we put all these values, we'll get omega n approximately 3 kilo radian per second. So in this way we can get the required value, means whatever asked in the question, in this way we will get the value. We have asked to find the thickness of the diaphragm as well as the natural frequency of the diaphragm. We just have to remember these formulas. For our upcoming exam, upcoming GATE examination. So thank you, and I hope you all have understood all these knowledges, all these concepts, and thank you very much.